So, center of mass. We're going to do this with. Everybody say hi, Sam.
Hi, Sam. Sam, are you hydrated? Do you have your water bottle?
All right. So, we've done center of mass before. And this does not require calculus. Okay. So we can pick the origin anywhere we want to. So just for kicks and giggles, I will do that. We'll make the origin at the center of that, just to like highlight some things. And go ahead and find the center of mass. That's at the end of the semester.
Oh no!
Doesn't have to be.
As long as the rate is described by some polynomial, fine.
All right. Calculate that. So you can either do it here or you can do it at the end of the hallway. Okay.
First semester last year. I turned well. Mine's still. Oh no, they did because someone had it. It's like that one meme. Their parents and their kids Brad's the one for English and Daniel's the one for grammar. I'm the skeleton of the population. I'm living. And this class can
Okay, so we're gonna make the center of mass of these spheres at the center at their center. And make sure that's a -4 meters over so you get -8, you get -2 over 6, so 1/3, -1/3. Okay, so this is like the balancing point. Okay, it should look, if it's drawn to scale, it should, like, you put your finger here and it should look like it'll balance. Okay. Now, the center of mass of two dimensionals. Okay, it's the same idea. But you do it in each dimension. So okay, so I'm going to make this my origin. Okay, so looking at the x direction first, this guy does not have an x component. So it's 3 kilograms times 0 plus 2 kilograms times 0 plus 1 kilogram times 4 meters over 6 kilograms. You get 2/3, oops, 2/3 meters, yeah, for the X, okay? Right, 4 over 6. Yep. So it's somewhere, here's 2, 1, 2/3, like somewhere in here. Okay, so if you had a knife edge and you placed it along here, this will teeter-totter, this will balance this way. Okay, and then the Y, we got 3 kilograms times 6 plus 2 kilograms times 0 plus 1 kilogram times 0 over 6 kilograms, and that ends up being 3 meters. Yeah. So 3 meters if you had a knife edge, this thing would teeter, balance this way. If this was connected by some invisible massless plane, you could just put your finger here and balance it. Okay. And that is how these work. Oh, this one's been dropped. 1, 2. This is
That's true.
this one works.
Oh, okay.
Okay.
That's cool.
So you can pass that around and balance it on your finger on the beak.
It's probably a big
Well,
Are there 14 questions or 12?
just 12.
Oh, I am done.
Okay.
I keep spelling.
There's a paper towel.
You have to use it to solve that one.
No, the weights and the wings went away.
Anybody want this?
Yeah.
You can throw it off the trebuchet.
I want-
Yeah,
I'm-
put it in the trebuchet.
Okay, I'll make sure you can launch it off the trebuchet.
Thank you, sir. You too.
Grab the center of mass.
Okay. So that's how you do things with algebra. With calculus,
Oh, no. Oh, no.
It works, it's just the center of mass is in a different spot.
okay, so we're adding up small pieces of mass a certain distance away. You okay with that? Over the entire mass. I mean, if you want to go like hardcore, I think this is kind of redundant. But
Yes, it's funny.
you could, some textbooks I've seen it written like this, but that's just going to be your total mass. Okay. So the hope is that after doing the integral worksheet, that this kind of makes sense. This is the hope. Okay. Now, you're right. Can you evaluate this integral? This needs to agree with the limits of integration in this. Okay. So you're going to have to do some stuff, which here we do. Here we go. We're going to do some stuff. Okay. So you know where the center of mass of this uniformly. Yep. If you like balance it like a broomstick, yes. But you've got mass M, you got length L. We know what that is already. Set up the integral to figure out how you would go about proving that the center of mass is at the center of the rod. Oh yeah, I mean they're doing physics. Do what?
But did they use summation for the integral? Or was it just like basic algebra?
Basic algebra. Like you can things that weren't uniformly dense were like, let's balance it.
Yeah, just approximate.
Like you can, yeah. I mean, they're all about like using geometry and like it's close. Approximating.
What's the first physics?
The first physics.
Before there were multiple physics. What was the first physics? That's so
Yeah, we could do an X.
No, that's not what I was going for.
Just to make it.
It's not XDX.
Yeah. You're right.
Tyler, what do you get for the
Hold on. I'll spread up here.
No, I'm sure you. Yeah, I've never played Fortnite. I know that's like a.
Okay, we'll make sure.
Sounds very addicting. Like it was a.
Yeah, I'll buy you Rick for Rick and Morty. No
Yeah,
way,
it's
I
like
can't
this.
do that. Rick, never mind.
It's like this. You can build them.
I can get you Mr. Meat.
Oh yeah. Good. Okay.
Oh, yeah.
You get mine. That's really good, actually.
I'm so excited.
It's like actually the before.
People were complaining about
Okay. So
It actually stinks about
this is kind of. I would not recommend you doing it this way unless they specifically force you to do this on a free response.
Where do you get the 1/2 from?
When I integrate X to the first, add 1, and then divide by. Do what?
Guess who got this working?
Now you're gonna be. Oh, Mr. Smiley.
Whoa!
So
Oh, you just subbed it. Yeah, that's extra piece.
Yeah, just play it once.
so I'll give you a head start.
Tim got run over by a gator.
Oh no.
What did you say?
The reindeer got my. Oh man.
I really don't like that song.
Oh,
DX. You don't
No,
like
it's not
You don't like the song?
DL or DX. You're right.
Okay, what's wrong with this song?
It's not better.
DL is a
Grandma got run over by a
DX
DX
is
in
like
the ballad. It's the best song.
DL is.
I'm in the process, okay? Chill.
are you in music theory?
No, I don't need music theory.
Oh, you just gotta put notes.
I know music theory.
But you really doing it for a second.
We need DX in the right.
I'm working on this swinging ballad, Rudolph the Grandma got run over by. It's so good, Mr. Smiley. It's so cool. It's got little saxo leads
Yeah.
and everything. Yeah.
You haven't started it.
I have started it.
Right here.
I just need to figure out what the notes are. Perfect video lickers.
All right.
I don't have it open.
So I'm gonna do. Oh, sorry, X. Let's do X.
Yeah, especially when it says lambda in terms of X.
Yeah, it's true. I don't win this stuff. That's my favorite.
Okay. So
You are leaning over talking phone during it.
You do nothing.
You constantly ask me like, you think I'm choosing about you? I'm like, no.
I've never had to say that.
I have a 0.
You're right. Sorry, you asked about Berkeley.
Which is
And your answer's still the same. What?
How you're?
Yeah, we'll go to Berkeley.
I thought you said Princeton. Is that Berkeley?
That's just easy.
I thought about going.
He hates it.
What?
He hates it.
Yeah,
Yeah,
you didn't like it
Wait, what? I hate it?
Yeah.
Call me.
I hate my side people. So.
Smiling.
I got the question right.
Good job. It's
I
the material right there.
It's not. No, I think it's not. It's a public school. Oh, so they're
It probably takes weight and state.
I don't know what this is. Brian said like 80% of the Brian said that like so I want to.
I would give it UCSC.
Isn't it located in Mill Village? No. UCSD.
I've lived there.
It's like the nicest campus ever. Oh,
There's
yeah,
UCSD
I
and
thought
the
you said-
USD.
I thought you said USS. USC. That was also not Mill. It is. That one
It'd be like good for you. Maybe if you're
University of Chicago.
Yeah,
All right.
That's in Chicago.
Yeah.
In the middle of the
I don't know about that.
And I guess here's something I need to specify. I made this my origin.
Welcome to America.
Yeah, you make it where it's a density of 1, yours.
exponentially more dense.
No, it's not exponentially more dense.
It's literally.
Well,
Well, it's not exponentially.
it's not exponential growth.
No.
Way more dense.
Hey Siri, you guys see located in the hood? I'm literally doing the that better not say yes.
And
Like crime rate. There's some really nice schools that aren't.
there are.
You Chicago?
Yes.
Wait.
Dude, I hear that.
Rose Bowl. You know, Terre Haute. The hood in Terre Haute. Dude, my grandma grew up in Terre Haute.
All right. So here,
That's a good thing for
if you have uniformly dense rods or pipes or whatever this is, okay. Here's what you're gonna do. You're gonna find the center of mass of each of the members here. And then you're going to find the center of mass of those points that have some mass. Okay? They don't give you a mass, but you can just say, well, this is mass M. This is also mass M. And this is going to be half of mass.
That was like definitely mass.
Okay? And so I'm going to make this my origin. Hey. So I've got M times 0 plus M times L over 2. That's M over 2 times L. What's the question? Over 2.5 M. You good with that? Okay. And then your Y is M L over 2 plus M times 0 M over 2 L over 4 over 2.5 M. That simplifies down to something that would look like ish.
Physics.
Right there. Perfect. That's the center of mass.
Are you gonna have to shake?
I am gonna share.
Did you do it last year?
No way.
Isn't that only the seniors?
Yeah.
No, really?
Okay. Good with that?
Maybe like band like.
Oh dear. All right.
You don't need to do it.
All right. Here's some tricks. I want to find the center of mass of this thing. Okay. So what we're going to do is consider this as two discs, like two cake that's layered. Okay. So we have the center of mass of the top layer, and then the center of mass of the base layer. Okay. to find the center of mass of this thing, we would just do so you have a certain mass of this, uniformly dense. We're gonna assume that the width of it isn't very much. So this is the area as surface area density. So this is going to be pi capital R squared, capital R being that, capital R being, well, lowercase r from that way that defined it.
Then you use capital R for the smaller circle.
We could do that, or we could do like.
We could also do a half.
You guys do cursive anymore? Is that a thing?
I know cursive. I don't use it.
Okay. So this is still equal to.
It's not legible.
Couldn't you just do half of that?
It is R.
Wow. That's right. Oh, wow.
Would it be half? I don't think it would be half.
No, cursive R is R over 2.
Oh, that's true. I like that. That's better. Okay.
How would you braille?
So,
What?
so you can make that the origin. Figure out the center of mass of that.
Did you mean to ask how to lie to people?
Stick figures made out of crayon. Just
You
connect the
know,
dots.
she
I do not want context to it.
It's the same joke I was gonna make, bro.
Yes.
What's that symbol thing on the left?
This sigma. This is surface. Yeah. Surface density. So it's the two-dimensional.
It's the lowercase.
Yeah. It's the surface. It's like two-dimensional density versus three-dimensional. The volumetric density is what we're used to. The density.
I just didn't know the symbol.
Yeah. Sigma. Lowercase sigma.
That's definitely before calculus.
Ugh.
I took math backwards. I started with multi-beam and then in first grade algebra.
First grade
algebra.
First grade algebra. I'm gonna be honest, I never really learned the statistics between algebra and anything else. So algebra has variables. I know. I learned that recently. For a long time, I was like, oh yeah.
All right. So anyway, simplify that junk. I mean, it simplifies, sort of. I mean, the pies cancel. Some of the R's go away. The M's go away. A lot of stuff goes away.
I can do it. I don't want to.
Okay. That's not what I'm trying to. But you can do that. Okay.
Unless we can factor out an M from the bottom.
No,
1 plus that annoying fraction.
It'd be over 1/6.
Right. The M's cancel, but the R's don't down here with this. This, you're doing the same thing, but you just pretend that this is negative mass.
So those pies cancel. So the R, so 4 goes to the bottom.
Okay.
And the R squared cancel.
Get rid of that.
Yeah.
Is that all you do?
Yep.
You just take it out. Just do it normally.
Match is effective. Make it
That makes sense.
the Illuminati of mass.
Okay. So there's some tricks of the trade. Center of mass.
So it's the same answer, just opposite direction.
Like whatever this distance is,
It's just the other way.
it's just right here. Okay. All right. Let's. I think you had this last year. This one caused a lot of turmoil. I think it's going to cause less turmoil. Turmoil. I think it's going to be better now that you know some more stuff, been exposed.
Are you sure that you have a 1 in 3 chance?
Could be easier, right?
Okay. Where exactly is that X?
Oh. Yeah. I get you.
Is the X at the intersection or where
Yes,
is it?
the intersection. Bless you.
Wait, right again? Neither of you are helpful.
Thumbs up when you have a guess. Have a conversation.
Assuming I like small.
The center of this is
It's almost like you're treading shit.
Balance
Yeah, but somehow we don't know.
Okay. What do you say? Correct answer is A. Good. You look at torque. This distance here is shorter than the distance between that center of mass. Therefore, in order to balance it, there's more mass there.
University of Iowa just sent me an email. I put a spell on you, and now you're mine, Brett.
Iowa's got some stuff going on.
What? They've cursed me to go to Iowa.
Oh,
That's Iowa.
It's too bad.
Hell, you had to go to the hood in USC.
I'm not going to go to just the hood, bro.
He's gonna use getting a major out of math.
That means you could have multiplied your own answer by R too.
My Brad was
There has been one. Dating Dan.
I thought you
Then
had
how are we
two- I thought you had two
set off?
tricks.
No homo. No homo.
Breaking
Straight
bread.
up. You'll be the troublesome student. You can
It's in
talk
the
about
biography of
smiley
this class.
Don't trip on shit.
Breaking bread. AKA physics.
Okay, what do you say? Correct answer is A. So the center of mass of the top half is like here. Center of mass of the bottom half is here. Add those two together, you get there. But now, center of mass of the top half is now here, which is going to make it, here's your, maybe higher now. Good with that? All right, so, oh buddy. All right, so center of mass, location of center of mass is that. If you take this and divide it by time, you get the velocity of the center of mass. But you have to divide this by time as well. So this is just distributing that division of time. Okay? So you get velocity. Okay? So what this is saying is all the pieces, the mass times the velocity of that piece, vector, like it's a vector, plus mass times the velocity of that piece, add it all together, divided by the total mass is going to give you the velocity of the center of mass of the system.
I'm assuming this is the same thing, but like slightly more complicated for angular momentum. Or did I just open up a whole new can?
No, you opened up a worm of cans.
No.
Let me chew on that before I give a definitive answer on that one.
I look what you did.
All right.
Unless you ask Isaac. It's a vector.
That's not. Easy vector. Just like all units are.
Isaac is a vector.
Why were you? You don't want to have
I've been called an absence.
Yo. Brad's nickname in high school.
I went on phase where I would get that. That was my nickname in high school. All the time. That may still haven't ended.
Well, you're still in high school, and it was your nickname at some point, so. I thought you just said it was.
Absolutely.
Are you committing fraud?
No, I said random crap like a joke.
Why were you like this?
My reason to be perfect. I was trying to figure out what to say from the letter of record.
Do I?
At least make sure check your pattern. At least check your pattern.
Oh, that's cool.
Okay. Tell your neighbor.
Yeah.
How neat is that? This one's like nice. This is $40. You know what else you can get for $40 just like that? Like so much.
All right. Correct answer is D. D. Donuts.
Okay.
Dinosaurs. All right. So we've got this expression for the velocity of the center of mass. If we take this total mass and bring that over here, what that gives us is the mass of the system times the velocity of the center of mass of the system, which is the total momentum of the system, which is equal to mass times V1 plus mass times V2. Okay. Which says if you discern that a system's momentum is conserved, then the velocity of the center of mass remains constant, which is a factoid I gave you last year. Pretty sure I showed you this video.
Yeah, I don't have enough context to remember.
Oh, wait for it.